Welcome to Investigation 2.2, Supporting the World, Congruent Triangles number 1. So this is a launch problem into congruent triangles. You guys are going to be deciding whether or not a set of triangles are congruent. You're going to go through Investigation A through F, I believe. Let me make positive. Yep, A through F. And as you do that, you're going to essentially decide whether or not a triangle is congruent to another triangle. And you're going to identify the sides that sort of match each other on each of the triangles and the angles that match each other. So you're going to be using a lot of the same symbols as what we described in Investigation 2.1. So some of those symbols will be congruency. You'll see angle measure. You're going to see that bar over a set of letters to describe a segment, and you're going to also see this arrow for corresponding to. So we're going to say one side is corresponding to another. So our focus question for this investigation is, how much information do you need to determine if two triangles are congruent? At the beginning of this, we are literally going to be measuring every single angle and every single side of triangles and to determine if they're congruent. Then eventually, hopefully, you'll find that there's some little sort of sneaky moves that you can make, and you can't really make those until you're probably at question E or question F, but you'll start to see them after a while, and Investigation 2.3 will really solidify that. So let's move on and read a little bit in the book. So in problem 2.1, you match the quadrilateral ABCD to the quadrilateral PQRS. One sequence of transformations that accomplish this is shown below. Since you can move the quadrilateral ABCD onto a quadrilateral RPSQ, you know that these shapes are congruent. So essentially, what we could do is we could make a slide move. We could translate the shape. Looks like approximately half the distance of AD, and then after that we could rotate it around angle P, or around point P, and eventually get ABCD to sit on the same shape RSPQ. And notice that I said ABCD, and then I looked at the same letter or orientation of that letter to start the next one, and I said RSPQ. That's super important because as you describe shapes, if certain shapes match other shapes, you need to make sure you describe them in a way that makes sense with that scenario. So let's look at a little bit more reading, and then we will jump into our very first problem. In this problem, you're going to focus on congruent triangles. Triangles are a very special family of geometric figures. They're used in many construction projects to provide strength and stability for structures. For example, there is a photograph in the book of the Washington Bridge and connecting New Jersey and New York City, and it shows that there's congruent triangles in the bridge's towers. So the bridge is shaped approximately like this, but there are triangles that sort of support that bridge all the way through it, and those triangles are what provide that stability. In all reality, 3 legs are actually more stable than 4, and oftentimes you can end up getting a little wobbly if you have 4 legs. So just keep that in mind the next time you decide to build a table or a set of chairs, perhaps. Anyways, let's move on. So for each pair of triangles in this investigation, you are going to need to do the following 3 things. You are going to need to inspect and measure parts of the figure to determine whether they are congruent, and I want you to measure everything. You need to be able to prove to yourself and to me that each of these triangles are congruent at first. After a while, you'll be able to eventually minimize your measurements to just a few specific things, but until you get to that point, I need you to measure everything. All of the angles, all of the line segments on each of the triangles. If you determine that the triangles are congruent, you need to list the corresponding vertices. So you need to list the angles that go together. And if the triangles are congruent, you need to describe a sequence of transformations that would move one triangle onto the other. So, kind of fun. Let's look at our first set of triangles. We're going to do part A. So part A looks like this. Here are our triangles. We have ABC and XYZ, and we need to determine if they're congruent. Just looking at them, ABC and XYZ, they look like they're pretty similar in shape. It looks like they have one big angle here that at B and Y, and it looks like vertex A and Z potentially could be congruent to each other, and C and X. Now we don't want to stick with this right now, so I'm going to erase this, but at the same time, we can at least see that there might be some similarities. That won't be the case for every problem in this investigation, so keep that in mind. So let's do a couple of measurements. I've made a couple of measurements here. I decided to make this measurement on angle A, and I found out that angle A is equal to 30 degrees. So that's kind of cool. I also found that angle Z right here is also, angle Z is also 30 degrees. So we're going to put this information in a table. So whenever you're doing these problems, I want you to make yourself this sort of table. A table of values for one of the triangles and a table of values for the other triangle. If you notice, I have all of my angles listed for both of the triangles and then all of the line segments, just so I can see and compare the two bits of information that I'm eventually going to get. So we have angle A, we found out that was 30 degrees, so we're going to put that in our table. And we also found out that angle Z was 30 degrees. Now we need to figure out what some of the line segments are, so I'm going to show you how to do that. And then after that I'll do a little math magic and fill everything in. So let's look at a couple of line segments. We have AC highlighted here. It looks like it is 4.6 centimeters, or I'm also going to write this as 46 millimeters. And then it also looks like I have XZ, and that's the same thing. It looks like we are at 4.6 centimeters right there. And we could also write that as 46 millimeters. So now we're going to add that to our table of values up here. AC was, or CA was 46 millimeters, and XZ is 46 millimeters. So now we're going to fill in the rest of the information. I'm going to just add it in, a little math magic. Hold on for a second. So I've filled in the rest of the table. It looks like we have B as 90 degrees, C is 60 degrees. We have AB is 41 millimeters, BC is 23 millimeters, and CA, we already knew that was 46. And we have similar measurements for our other sides. So let's look at this. I'm going to color code it, and we're going to zoom in on our triangle and see all of this information in action. We have angle A. We said that was 30 degrees, and that is congruent to angle Z. Notice that I'm putting one of those angle marks. We have angle C was equal to 60 degrees, so there's two angle marks. It's different than 30 degrees, but it's similar, or it's congruent to angle X. And then lastly, we have angle B, which was 90 degrees, and that is congruent to angle Y at 90 degrees as well. So we have our three angles. It looks like if I look at triangle ABC, if I were to twist it, if I were to sort of rotate it 180 degrees, I would have it looks like I'd have the same angles in the same places. So it looks like I'd have to rotate this to here, and then B would come around here and C would come up there if I were to do that. So just looking at that at least describes a little bit for me. Let's also look at the side lengths. We have AB, that was 41 millimeters, sorry, and that is congruent to leg YZ, which was also 41. Notice that I put one tick mark through each of those. Then we have BC, which was equal to 23 millimeters, and XY also equal to 23 millimeters. And very last one, 3 tick marks. The hypotenuse, AC, and I can say it's a hypotenuse because we have technically, if I wanted to, I could erase this and say this is just a right angle and say that. We could also say it here. So we have 2 right angles, 90 degrees. I have now my 3 tick marks across from the hypotenuse. That is 46 millimeters, and we have our 3 tick marks on the other hypotenuse, XZ. So just looking at this information, I can clearly see that this is a rotation and a translation sort of situation. If we were to look at this, we now need to finish up this problem by describing a little bit and describing some of the congruent vertices. So the triangles, we can say yes, yes, it is congruent. Our vertices that correspond, we could say angle A. I'm going to zoom in here so we're not writing so little in such a small place, or so big in such a small space. We have angle A corresponds to angle Z. We can also say that angle B corresponds to angle Y, and angle C corresponds to angle X. We also need to describe what sort of transformation we could make. Essentially, if I were to look at this, if I see that we have ABC, I'm stepping back a little bit. If I have triangle ABC, I could say triangle ABC is congruent to, and now I'm going to pay attention to A corresponded to Z, so triangle ZYX. So triangle ABC corresponds to triangle ZYX. So now all we need to do is we need to be able to describe the transformation that we need to make this first triangle correspond to the second triangle and prove that they are congruent. And one thing I would like to say is potentially I could rotate it, about this point. If I were to rotate this about this point, especially if it were the same distance from here to here, the same distance from A to Z, and the same distance for B to Y, I would be able to rotate this about that point 180 degrees. So I would need to take C and rotate it to X. So my very last step was describing that transformation that I could make. Another transformation I could potentially make would be I could potentially rotate it about point C, and my triangle would be down there somewhere, and then I would have to translate it up a certain distance. That's also a possibility for a transformation that we could make with this particular triangle set. We could also do potentially a couple of reflections. We could do a reflection horizontally and then a reflection vertically, and then transform it or translate it over a couple of units or something like that. But that is our goal. Look and see what you need to do for each and every problem. First step is to measure. So you're going to measure. You're going to create a list like these for each triangle. And then very last, you are going to complete the steps. You're going to do this over and over the entire time until you finish investigation 2.2 A through F. So you're doing 2.2 A through F. Thank goodness we just completed A, so really in all reality you could skip that and do B through F. So you have 5 exercises to do. Enjoy, have a good time. Make sure you're being accurate and you're attending to precision using your ruler and your angle rulers. Be very careful about what you're doing. You do have a lab sheet that you can use with this. I suggest using it and taping all those triangles into your missing when you're finished. Thanks so much for watching and enjoy.